I'm stuck. I don't know what to do.
Okay, let's try. In these types of problems that we have integer part and something like that, consider x as k plus r. K is integer part, r is fractional part, okay? So what condition should be satisfied?
0 is less than or equal to r less than 1.
Exactly. So if you replace here, then it would be what?
X plus r squared minus 4k
K plus
minus 12.
r squared minus 4. K minus 12 is 0, right? Then do you agree it is a quadratic equation in terms of r?
Yeah.
And you can find, and it opens up or opens down?
Up.
So if you find the roots, let me tell you something. At first, let's solve the r in terms of that. So let's simplify r squared plus r times 2k, right? Plus k squared minus 4k minus 12 is 0, right? So r is what in terms of k?
Negative 2k plus or minus the square root of 4k squared minus 4 times 1 times k minus 6 times k plus 2.
Yeah, so it is 4k squared minus 4k squared plus 16k plus 48, right?
Yeah.
All over 2.
Over 2.
So it is negative k plus minus 4k plus 12, right?
Yeah. So
now it should select plus or minus.
Plus.
Why?
Because if it's minus, it will just make r negative. But if it's plus, then it could be between 0 and 1.
But maybe k is negative.
Oh, yeah.
So, for which k we can consider both positive and negative?
Negative. If k is negative, then consider minus.
So let's consider if k is negative, if you consider negative k minus this, it should be positive, right?
Yeah.
So negative k should be this, right? Negative k is positive, so we can raise both sides to the power of 2, right?
Yeah.
So k squared, right? So k squared minus 4k minus 12 is positive. So we can factorize like what?
K minus 6, k plus 2.
It's positive. The roots are what?
6 and negative 2.
So it should be outside of the roots, right?
Yeah.
So we can see for lots of cases it is okay to select, let me check, to select minus, right?
Yeah.
So we should, so if we want to work on this, we know that because this one should be greater than equal 0, not strictly, right? Because it is r. So we can conclude k is less than or equal negative 2 and k is less than or equal negative 2. R can be both of them, right?
Yeah.
But if k is at least negative 1, we should only consider what sign, plus or minus?
Plus.
Now let's consider next inequality. It should be less than 1, right?
Should it be 4k plus 12?
Oh yes, sorry, 4k plus 12. We should consider less than 1, right?
Yeah.
First consider this part that is less than 1 and see for which k it is possible, okay?
Okay.
And one important thing. Also, let's consider we can, because when k is positive, do you agree for large k this one would be negative?
Yeah.
For large k, because it is around the square root of k, it is around k. So because let's also
Yeah.
consider this one, negative k plus 4k plus 12. This one should be positive, greater than or equal 0. So try to work on this and see k is at most what, okay? Check this one.
Okay. So k has to be less than or equal to -2 and greater than 6.
Okay, if we check here, root 4k plus 12 is greater than or equal to k. So if you raise to the power of 2, then 0k squared again minus 4k minus 12. So when k, because we said k is at least -1, right?
Yeah.
Okay, for k at least -1, here because it opens up, it should be between the roots, right? -2 and 6. So we should consider which numbers?
Less or equal to -2, or greater than. Actually, no. I mean between -2 and 6.
-1 and 6, because
Oh yeah, -1 and 6.
yes, for k. So case 2 would be this. K greater than or equal greater than -1, less than or equal 6, and r is negative k only plus root 4k plus 12. And for case 1, we have this, right? Okay. Now, because we want to consider signs, let's check. For k -1, is it good or not? Is r good or not? R is what?
R is 1 plus 4, so 5.
It is not good, right?
Yeah.
So let's work on this part. Do you agree it should be less than 1?
Yeah.
So try to solve this in general and see what can we say about this. Okay.
Okay. Okay, so the roots would be 1 plus or minus the square root of 12.
K is integer, right? So could you find any relationship for k?
Um,
Which k's are good from -1 to 6?
-2 to 4.
No, -2 is here outside the range. You meant, I think, -1 to 4, right?
Yeah.
Okay, let's check. Here we can consider 4k plus 12 and less than 1 plus k. 1 plus k is greater than or equal to 0 because of this. So we can raise, because
Yeah.
both sides are positive in non-negative numbers, we can raise to the power of 2. So 4k plus 12 is less than k squared plus 2k plus 1, right? So you can say k squared minus 2k and greater than what? 11, right?
Yeah.
So k times k minus 2, because you can consider these. -1 satisfies or not? No. -2 satisfies or not? -2 times -4, sorry, for 0. 0 also doesn't satisfy, right?
Yeah.
1 doesn't satisfy, 2 doesn't satisfy. What about 3? Why you said all of them from negative to 4?
Because I got 1 plus and minus the square root of 12 is the roots.
So if you consider the roots also, you can check this. My calculation is correct, right? 12 minus 1, 11.
Yeah.
Okay, 4 works or not? 4 times 2, 8 doesn't work. 5 times 3, 15 works. Also 6 works, right? So for
Yeah.
5 and 6, we have, for each of them, we have one answer because we consider only plus, right?
Yeah.
So we found, and it says what? It says find sum of the squares of each of the roots of the equation. So let's check, for example, for 5. When k is 5, our answer is what? K5. X is k plus r, which is 5 here. Minus 5 plus minus 5 plus the square root of 4 times 5, 20 plus 12, 32. So it is the square root of 32, right?
Yeah.
For 6, it is 6 plus negative 6, right? Plus square root of 4 times 6 plus 12. 24 plus 12,
36.
36, right? So it is
Yeah.
6. Now, if we check this one, copy. You can say root 32 is what? 32 minus 4 times 5 minus 12 is 0. That's correct. For 6 also, 36 minus 24 minus 12, 36, 0. So we found, let me draw something around them. So our first answer is 32, right? Root 32. Our second answer is 6. Okay. Now we should
Okay.
focus on this part. That k is less than or equal negative 2. And try to solve this one first on your own, okay? Try to see, can you find any other answer?
I think only k equals negative 2 works.
Okay. So let's check. Minus k is negative, right? Minus k is positive, and we can say minus k minus 1 is less than. So it is a positive number. So if we consider negative plus 4k plus 12, right? Do you agree this one is positive?
Yeah.
So I'm thinking of something. Do you agree plus doesn't work?
Yeah.
Because it will
So
be
do
greater
negative.
than 1. So we should only consider minus, and when we take to right side, it will be plus, right?
Yeah.
So if we raise the power of 2k squared plus 2k plus 1 is less than 4k plus 12, right?
Yeah.
So we can say k squared minus 2k is less than 11. So k times k minus 2 less than 11. So for negative 2, it would be what?
8. So
Negative
works.
4, 8 is good. For negative 3, it would be large, right?
Yeah.
And
15.
after it is increasing, so for k negative 2, then n is what? N is k plus r. So it is k minus square root of 4k plus 12, right?
Yeah.
So it is x. So then x is negative 8 plus 12 root 4, right? So x is negative 2, right? And if you check it
Yeah.
here, it is 4 plus 8, 12 minus 12, 0. So another answer is negative 2, right? So if you check all the
Yeah.
answers, it says sum of the squares of each of the roots. So root 32 squared, 32 plus 36 plus 4, right? So the answer is what? 72. Agreed?
Yeah.
Okay, as homework 1, let me tell you an Amy problem that is similar to this one. What harder? It is this problem, okay? It is for Amy. I think we solved this one before, right? Remember we draw interval. I said, okay, consider f of x, then it goes to here. You can try this one again, but it is hard, and we will solve the same idea. You should divide it, split into integer part fraction of what k plus o, and consider this inequality, okay? So this idea is so much useful. Also in AMI and AMC also we have this. Now let's try next problem. For next problem, let's try 20. Try problem 20 first on your own, okay?
Okay. I need a hint.
So 1216 is what? 1216? If you prime factorize, it would be what?
2 to the 6 times 19.
2 to the 6?
Times 19.
Times 19, right?
Yeah.
Okay, let's check. If you divide by 8, 152. If you divide by 4, 38. So it is 8 times 8 times 90. Good. So we should split to two parts. We had similar problem. I don't know you remember problem in AMI or not. That had similar approach. Let me copy the problem. After this, you can solve also this AMI problem. It has exactly the same approach. And here you should consider as homework. You should consider 1000, and you should split to 2 cubed 5 cubed. Here we should split to 2 to the 6 and 19. So let's focus on 19. Could you solve this one mod 19? It is so much easy.
Yeah.
It is what?
1901 to the 18 is mod 1. I mean, it's converted to 1 mod 19.
So 1 to the this is 1, right?
Yeah.
Now we should only calculate 2 to the 16, right?
Yeah.
Okay, so here I am thinking of something. So let's try to calculate this number mod 2 to the 6. There are lots of ways. One way is this. Do you agree we can write 1900 plus 1 to the 2024?
Yeah.
So if you apply binomial theorem or binomial expansion, then I think some few terms will be left. All other terms will be 0 mod 64, and you can find this. One hint for this part, one more hint, or want to try on your own?
I think more hints.
Okay, so the first term is what? 1 to the 2024, which is 1, right? Next term is what? 2024, choose 1 times 1900, right? Next term is 2024, choose 2 times 1900 squared. Do you agree the rest will be 0? Because 1900, it is multiple of 4. So next one is has 4 cubed, 4 to the 8, right? 4 to the 4 and so on. So you should only calculate these three terms, mod 64. So calculate it.
Is it just 1?
1, okay, let's check. 2024, here it is multiple of 4.
Yeah.
2024 is 8 times what? 2 times 8, 16, 42, 5 times 6, 43, right?
Yeah.
Are you sure it's 1?
Wait, no, it's not 1.
This one I think is
That's
0, right?
that one's
Because it
0.
is 10, 12 times 20, 23. It is multiple of 4, right? It is 4 times 2, 5, 3. So 4, and here it is multiple of 16, 64. So this part is 0. So it is what mod 64?
41.
It is 41?
Yeah.
No, it is not 41. Calculate again.
I'm still getting 41.
1.
Yeah.
Look, do you agree? It is, this is multiple of 4, it is multiple of 8, right?
Yeah.
So this number is multiple of 32, right? And it is 32 times an odd number, right? 2q plus 1. Agreed?
Yeah.
So now can you say it is what mod 64?
33.
Understood?
Yeah.
So we don't need to calculate all numbers. We can write like this. So suppose this number is x. X is 1 mod 19. X is 33 mod 64. Now by using these two things, you can find x is what mod product, which is 12, 16. Want hint for this part or want to try on your own?
Try my own.
Okay, sure, try.
609.
609, can you explain your approach?
Yeah. So you can say x is equal to 19a plus 1. And then
Yes,
substitute
yes, your approach is correct, but usually when we have these, I start from larger number, because then after that working with a smaller mod is easier usually. Okay, so
Okay.
you start from here. I will start from here and compare which of them is easier. Okay.
Okay.
So it is 64a, for example, plus 33, right? Then
Yeah.
it is 1 mod 19, right? So
Yeah.
64 mod 19 is what?
7.
Yes. Is minus here 32, right? Minus 32 is what?
6.
Mod 19, right? Do you agree you can add 19 to, we can add 19, or let's consider something. We can add, multiply by 3. Then 21 is 2 and 18, right? Agreed?
Yeah. Yeah.
Then we can divide by 2, a mod 9. Mod 19 over what?
Over 2.
No, over GCD of 2 and 19, which is 1. So it will be 19.
Yeah.
So a is 19, b plus 9. So x is 64, 19b plus 9 plus 33, right?
Yeah.
So which is 12, 16. B, 9 times 64, 9 times 4, 36. We have 3. 9 times 6, 54, plus 3, 57. Plus 33. Which is 906. Your solution was easier or my solution?
Yours.
Because look, 19. But sometimes, for example, this number is so much large. For example, something like this, and this number is 3. Okay, so use this one and then work with mod 3. So much easier than this, right?
Yeah.
Understood completely? How to
Yeah.
solve this? Okay, 609. And you can solve this problem as homework. It is similar exactly, but harder. Okay, but the ideas are same. Now let's try another problem in number theory. Try this problem first on your own, okay?
Okay.
One hint.
Yeah.
Okay, again, instead of 96, we should write what?
2 to the 5th times 3.
Yes, so we should consider 3. And instead of, we know that x cubed plus 95 mod what is what?
Uh,
You should consider mod what?
32 and 3.
Yes, 32 and 3, but in the first step. If you consider mod 96, it is what? Instead of 95, we can write what?
X cubed is equal to 1.
Minus 1,
Oh, yeah,
right?
minus 1. Yeah.
Okay, so let's focus on 3. X cubed minus 1 is 0. It should be 0. Mod 3, right?
Yeah.
And also it is 0 mod 32. 32 is a bit harder, but 3 is easier. Could you solve this part? One hint for this part, want to try on your own for this part?
I'll try mine.
Okay, sure. For mod 3, could you reach any good result?
No.
So look, when we consider mod 3, you should consider x mod 3, 0, 1, 2, right? Only you should check this
Yeah.
for 0 plus minus 1, right?
Yeah.
So, which of them is possible? Look, x
1.
is 0 or 1 or negative 1. Only 1 is possible. So which part was hard?
Oh, that's it. Okay, yeah.
So x is 1 mod 3, right?
X.
It is our first.
Yeah.
Now here we should work on this part, right? Again, for this part, we should use LT, lifting the exponent. Have you heard lifting the exponent?
I think so.
In AMY useful, I will tell you a similar problem in AMY. You should use this part for this one. But pay attention here, because it is 2 to the 5, our P is not odd. You should consider this case. Okay, and you should see, are the conditions, for example, satisfied? If satisfied, use this formula. Here to see what can you conclude about X, okay? Try to see how you can apply LTE.
So in this case, would y equal 1 and n equal 3?
You've concluded what?
Would y equal 1 and but n has to be even.
Okay. So look here. We know that power of 2 of these should be at least what? Because it is multiple of these. V2 of x cubed
5.
minus at least what?
5.
Yes, and it satisfies this condition because x, we agree, should be odd. Because if x is even,
Yeah.
it doesn't satisfy. So, because x is odd, 2 doesn't divide x, 2 doesn't divide y, 1, and 2 divides x minus 1 because x is odd, right? So we can use this
Yeah.
formula, right? So it would be v2 of x minus 1 plus v2 of 3 plus v2 of x plus 1,
N have to
right?
be even.
You said what?
Doesn't n have to be even according to the condition?
Sorry. For even n, for even n. So because it is odd n, we should do what?
Square.
What do you mean by square?
Like say x to the 6 minus 1.
You can do x to the 6 minus 1. What? there are also some other approaches that we can use. So, we can prove something. Let's see. We want to see, is it correct for P2 when n is odd? Okay, so here we want to calculate V2 of x cubed minus 1. Is it equal to V2 of x minus 1 plus 3 is odd, right? So we want to see, are they equal or not? So can you say, are they equal or not? Try to check. Without LT also we can prove. So do you agree it would be this form of LT? Because V2 of 3 is odd, 1 is 0, right?
Yeah.
Okay, so this is x squared plus x. We know x is what? X is odd or even?
Odd.
Odd. X is 1 mod 2, we said. Now, can we say here these two are equal? It is correct. Try to prove this, okay?
Mm,
And it is not hard at all. Try to prove it. Want hint for the proof or want to prove it on your own?
I'll do it on my own.
Okay, sure.
Oh yeah, so if you say x equals 2q plus 1, then it works.
Why V2 of them are equal?
Because if you say x equals 2q plus 1, and
Yes.
expand,
With that way, yes, that's correct. Also, you can say x cubed minus 1 is x minus 1 times what?
x squared plus x plus 1.
So the second bracket is odd or even?
Odd.
So it has no effect, so the agree V2 of these two will be equal.
Yeah.
Okay, so we know it is equal to V2 of x minus 1, right? So we can conclude x minus 1 should be multiple of 32, right?
Yeah.
So x mod 32 is what then?
1.
Now x mod 32 is 1, x mod 3 is 1, so what can we conclude?
X is 1 mod 96.
Exactly. So how many answers are there?
9,000 divided by 96.
Yeah, say 96. It's better to write like this. It says positive integer, so at least 1. Less than, or let's write less than or equal 8999, right?
Yeah.
So 96q is what? Is at least 0 and less than 8998, right?
Yes.
So then we can divide q is at least 0 and at most what? Divide this one.
70. I mean, 93. 93.
93. So 93 point something, right?
Yeah.
So answer would be what then?
94.
Exactly. So here I told you homework 1, this one, homework 2, this one, and homework 3, similar problem again from Amy. So next session we will solve all problems related to homeworks of this session and previous session. In problem of Amy, let me see, okay, Amy, we had a problem. It is for 2020, Amy 1. Amy 1, LTE. Yes, I found it. For that problem, you should use again LTE, and you need to only use this box, okay?
Okay.
Okay, use this box and try to solve homework 3. And next session we'll work on that. Any question?
No.
Okay, so have a good day.
Thank you. You too.
You're welcome. Bye.
Bye-bye.